Kitty Hawk to Cape Kennedy. NASA, the National Aeronautics and Space Administration presents Aeronautics and Space Report. (1966), a year in which aeronautics and space achievements were much in the news, achievements which are expanding man's knowledge. Here is a report on some of those accomplishments. This animation shows how Surveyor 1 looked as it came in for a soft landing on the moon. The date, June 2nd. As evidenced by these photos, a spacecraft can land on the lunar surface, and probably a man can walk on it. Some of the terrain is very similar to our soil. A man would leave footprints as he would in sand. Many rocks dot the moonscape. Future flights will photograph other possible manned landing areas and carry instruments to measure surface hardness, information needed before men land there. Charting actual landing sites for the astronauts is the job of Lunar Orbiter. 2 of the 850-pound satellites have orbited the moon, photographing and mapping wide areas, sometimes sweeping as low as 25 miles above the surface. Here are some of the pictures helping to determine the height and slope of lunar mountains and the depth of craters. These remarkable views show the crater Copernicus. Pictures, too, of the backside of the moon, and a view of Earth from 240,000 miles in space. The Surveyor Lunar Orbiter combination has returned valuable scientific data about the moon, helping pave the way for the first lunar explorers. American weather satellites are a good example of technological potential put to work not only for our own well-being, but that of other nations. The high-flying picture takers have given advance warnings on everything from hurricanes in the Gulf of Mexico to great sandstorms in North Africa and Arabia. 3 satellites making up the Tyros operational system were launched for the Weather Bureau in 1966 and are returning daily meteorological information around the world. Nimbus, an advanced NASA research weather satellite, was also launched. Nimbus took both day and infrared nighttime pictures over the United States and of the entire Earth, predecessor to long-range weather forecasting systems. One of more than a dozen scientific satellites launched by NASA in 1966 was Orbiting Geophysical Observatory. Nicknamed OGO, it studies space phenomena such as radiation belts, solar plasma, magnetic fields, their effects on each other and the Earth. Another satellite is greatly refining our map-making ability. Appearing as a bright new star, it is called Pagios. Pagios carries no instruments. By reflecting sunlight from its 100-foot shiny surface, it provides an orbiting point source of light. Serving as a beacon in the sky, the satellite is simultaneously photographed by widely separated ground stations throughout the world. With the help of Pagios and using the principles of geometry, the Earth's surface can now be mapped with greatly increased accuracy. Two Pioneer spacecraft were launched into orbit around the Sun, Pioneers 6 and 7. Between now and 1970, an entire series of these Sun Watchers will be put into orbit around the Sun, investigating, reporting. Future Pioneers will venture even closer to the Sun, observing the solar atmosphere close up and warning of solar storms, sending back useful data about the Sun-Earth relationship. More than 300 sounding rockets were launched from various locations around the world. These small rockets play an important role as they scientifically probe the atmosphere and ionosphere, testing out equipment and experiments to be flown on future satellites and helping us better understand weather and communications. Sounding rockets, so reliable and flexible they can be launched during sub-zero weather or from on board a ship at sea to take measurements during a solar eclipse. Total eclipses happen only once every 2 years. November 12, 1966 was the date of one of these occurrences. The place, South America. Certain celestial phenomena can be recorded only when a total eclipse blots out the sun's direct light. 300 scientists from the U.S. and other countries, complete with equipment, gathered in South America to witness and record the event. Some flew on high-speed jets, which intercepted the moon's shadow and then raced along with it out over the Atlantic. Others used sounding rockets to record changes in winds and temperatures and make X-ray measurements. As the moon's shadow swept from coast to coast across South America, scientists had an opportunity to acquire a history of a complete solar event in a cooperative international program. This is the Hypersonic Research Vehicle, X-15, a rocket, airplane, and spacecraft in one. In the atmosphere, it flies like an airplane. At the edge of space, it is controlled by Gemini-type reaction jets. On November 18th, the X-15 rocketed to a world record speed for winged aircraft, 4,159 miles per hour. The sleek black plane has also reached altitudes of more than 67 miles. But the X-15 is more than all this. It is a flying research laboratory making contributions that range from bioastronautics to future leadership in high-speed, high-altitude, supersonic, and hypersonic flight. There may be a need someday to shuttle men and equipment between orbiting space stations and Earth. It is for this reason that NASA has been studying lifting bodies. This prototype, called the M2F2, is one of the lifting bodies currently undergoing tests. Wingless lifting bodies are being developed to operate in space, then return through the Earth's atmosphere, landing like a conventional airplane. Research continued in developing systems that might power future space missions, yet undefined. Present-day rockets are, for the most part, liquid fuel. Now under study are solid propellant rockets of equal or greater thrust. The Florida Everglades was the site of the second test firing of a powerful solid fuel rocket motor. The 8-story tall motor spewed out a pillar of white-hot flame from its exhaust nozzle. The so-called large solid burned 840 tons of rubber-like fuel at a rate of 6 tons per second. Also in the research stage, nuclear propulsion engines. A series of tests are being jointly conducted by NASA and the Atomic Energy Commission. The rocket would use a nuclear reactor to produce thrust. Small, less fuel-consuming nuclear engines being tested now may someday enable scientists to plan long missions to distant points in space and carry greater payloads. Project Gemini, this country's second manned venture into space, falls between the experimental Mercury program of the early 60s and operational Apollo flights. We've gained much experience from Gemini, nearly 2,000 man-hours in space, experience which has direct application to the Apollo program. There were 5 Gemini flights during the year, rounding out a series of 12, 10 manned, 2 unmanned. Gemini operated in a building block fashion. Experience learned from one mission was applied to the next. This included both the successes and failures. Gemini's major requirements: rendezvous and docking, long-duration missions, learning to work in space, and the ability to bring a spacecraft down to Earth close to a desired landing point. By the end of 1965, we had satisfied the long-duration mission requirement. During March 1966, Gemini 8 astronauts Armstrong and Scott carried out the first rendezvous and docking with an orbiting Agena, but all did not go well. A malfunction caused the spacecraft to roll erratically. The crew was forced to undock and make an early landing in the Pacific, proving the ability to evolve alternate plans, to learn from the unexpected. Gemini 9 had a double problem. The Agena could not be put into orbit, and as you can see here, the shroud surrounding a substitute target did not come completely off. Even so, Stafford and Cernan rendezvoused 3 separate times with what they called the Angry Alligator, and Cernan spent more than 1 orbit outside the spacecraft. Then Gemini 10, when astronauts Young and Collins met with and latched onto an orbiting Agena. The docked craft then powered up to rendezvous with the Agena vehicle left in space from the Gemini 8 mission. In addition, Mike Collins became the 3rd American to practice extravehicular activity, although trouble with his oxygen system shortened the spacewalk. Gemini 11 was also a successful flight. A new altitude record of 860 miles was established with the docked Gemini-Agena combination. As in the 2 previous missions, EVA was cut short, this time because of fatigue. But Gemini 12 showed how man could work more productively outside his spaceship. Astronaut Edwin Aldrin, using special handholds, tethers, and foot restraints to counteract the effects of weightlessness, spent more than 5 hours outside the craft, completing all his EVA tasks. A 100-foot line was attached between Agena and Gemini, conserving valuable fuel, and even creating a small amount of artificial gravity. During all the Gemini missions, many important scientific and engineering experiments were carried out, and hundreds of photographs like these are giving us a better understanding of our Earth. Of special significance, too, has been the ability gained to control a spacecraft during the all-important re-entry, an ability which has allowed Gemini to land within full view of the recovery forces. Gemini has prepared us well for all future manned missions into space. "1966 was a year of development and testing for Apollo Saturn. Escape systems, fuel cells, spacecraft, all the major components are being worked up to a state of readiness. 3 uprated Saturn I rockets were sent aloft from Cape Kennedy to check out the performance of the launch vehicle and unmanned spacecraft. All went well, including recovery in the South Atlantic. This a prelude to manned Apollo missions. At the Kennedy Space Center, a full-scale engineering model of Apollo and the Saturn V rocket were put together inside the newly built Vehicle Assembly Building. From there, a giant crawler transported the rocket and craft to the launch pad 3 miles away. 1966, a year of exploration and investigation, whether building toward faster, more efficient planes of the future, developing space hardware at industrial plants throughout the United States, or performing basic research at university and government laboratories. 1966 was a year of progress in both aeronautics and this country's continuing peaceful exploration of space.
This has been an Aeronautics and Space Report, presented by NASA, the National Aeronautics and Space Administration.